Alright, so I just wanted to create a short video just to show you how to use Excel in order to crunch some of the numbers and plot some of the data that you collected in your conductivity experiment. So up here on the left side of the screen, I have my data entered, and I have all three of them entered for the sodium chloride, the calcium chloride, and the aluminum chloride, as a function of the number of drops that were added for each of those solutions. So I would encourage you to actually enter your data into Excel this way, because when you convert this to a graph, it actually becomes very, very quick and efficient. So the first thing we're going to do is to highlight the data that we want to plot. So I'm just going to click on the data points and click and drag my mouse to select all of the data. So the drops, in addition to the conductivities for each of the solutions. And then I'm going to go up to the top of the screen and select Insert and scroll over to the Charts subcategory. I'm going to click on the one here with the dots. It says Insert Scatter or Bubble Chart. I click on the down arrow and I'm going to hover over the scatter plot and click on it, and automatically it's going to populate it with a plot of all that data, color-coded according to the three different categories that I have. So when we select this data here in Excel, Excel recognizes this first column as the X values. So this would be the number of drops that would be along this axis here. And it plots the next three columns as the Y values, which would be the conductivity over in this region here. So you'll notice that the data points here are color coded. So for example, if I click on the graph any of these gray data points, you will see the data that's highlighted on the Excel cells that we have here. So clicking on the gray data point, you can see it's plotting the number of drops and the conductivity for the aluminum chloride, the AlCl3. If I click on the orange data points, it's plotting the conductivity of the calcium chloride versus the number of drops. And if I click on the blue dots, it's plotting the conductivity of the sodium chloride versus the number of drops. So it automatically plots that data for me. So what I need to do is I need to then go ahead and generate the line of best fit, straight line of best fit through all of these data points for the three different solutions. So I'm first going to do it for the sodium chloride. So I'm just going to right click on any of the blue data points. So if I right click on it, it gives me several options. I'm going to go down to add trend line, and over on the right side I get some options. You want to select linear, which automatically selects. And if you scroll down, we want to display the equation on the chart. You'll need that equation. And then the R squared value, which just kind of tells you how your data fits. So what we'll see now is over here on our graph, we have our straight line, the blue dotted line, the straight line of best fit. There's my equation for the line and my R squared value. So the closer this R squared value is for 1 to 1, the closer all your points are going to fit along this line of best fit, right? So 0.9823 is fairly close to 1, but it's not exactly 1. I can do the same thing for my other data points. So if I go on the orange, click on any of these, I add a trend line and do the same thing. I select linear, go down to display equation, display the R squared value, and you can see now, right, I'm just clicking on the boxed area and pulling it off to the side a little bit. You can see the R squared value here is a lot closer to 1. It's 0.9996, and that makes sense because all of my points actually fit really close to that line of best fit. And then I'm going to go up here to the third. That's the aluminum chloride as shown here. I'm going to add a trend line, linear, and display the equation and R squared value, and it automatically does it for me here on the graph. Alright, so I have my three graphs plotted. I need to do a couple things with my graph here. Whenever you have a a graph in Excel, you want to make sure that you have the different axes labeled, so the y-axis and the x-axis. We also need to include a title for our chart. So there are a couple of ways we can access that. We can either just right-click on the chart title and we can rename it over here, or if you wanted to, you can click on this plus button and it brings up some options. If I click on axis title, it'll give me spaces to enter a title for each of my axes if I wanted to. So I'm going to do that because I need to label my axes. On the on the x-axis down here on the bottom, that should be number of drops. On the y-axis, this would be conductivity. Okay, so let's name that. And that you need to include the units. That's in microsieverts per centimeter. The number of drops on the x-axis, that's just the unit number of drops. I also need to include a title for my chart, and this would be a plot of conductivity of various ionic solutions, or various aqueous solutions. Alright, so you have your graph with a proper title. The axes are labeled. You'll notice down here we have several of these, like a legend. We need to tell the viewer, whoever is watching and reading this graph, what these numbers actually mean. Alright, so if you recall, the gray line and the gray dots correspond to the aluminum chloride. The orange correspond to the calcium chloride, and the blue correspond to the sodium chloride. So we need to include that in our legend down here, and there are a couple of ways we can do that. If you go to any of these data points and I right click, I can select the data if I wanted to. So that's my series 1. I'm going to edit that and I'm going to name it as sodium chloride, NaCl. Okay, and you'll see it changes it down here to NaCl. Series 2, I'm going to edit that to calcium chloride, CaCl2. So that's the orange one now, and then the gray, that's series 3, I'm going to edit that to be aluminum chloride, AlCl3. Okay, so you'll notice now my legend down here on the bottom accurately reflects what it is that I'm plotting on the graph.